A very lovely hello to all my class 10th champions. First of all, congratulations everyone, as you all have been promoted to 10th standard. Now you all are board students and your new journey starts from here, my dear champions. So congratulations again. And here I have come up with very first chapter of your maths, that is real numbers, my dear champion. So this video is going to be one short video. In this video, I'll be teaching you concepts, PYQs also, and few questions from R.D. Sharma and R.S. Agarwal that you generally solves. But my dear champion, this is my genuine suggestion to you all. You should solve questions from R.D. Sharma and R.S. Agarwal, but always make sure to solve each and every question, including example of NCERT textbook first. Always give priority to NCERT. When you are done with NCERT, you have solved each and every question, then you should move and you can move to the next any reference book, whether it is R.D. Sharma or R.S. Agarwal. But you should give priority to NCERT first, my dear champion, because sometimes direct question comes up from NCERT in your board exam. And again, congratulations. So let's begin this one short video of real numbers, my dear champion. So here in this video, today's goal will be what we are going to do here in this video, means aim of this video, introduction to number system. What is called number system? What is number system? So introduction I'll be giving you. Fundamental theory of arithmetic, very important. Very important. I can say here, my dear champion, 70% of the question is based from this theorem, in which we'll be talking about how to find HCF and LCM between two numbers, three numbers and all, right? So fundamental theorem of arithmetic is very important. I should write here, very important. Third will be HCF and LCM. Look, my dear champion, this point HCF and LCM is coming after this theorem, because this particular concept comes under this theorem basically. So HCF and LCM and relationship between them, this is also very important as per the board examination point of view. Word problem on HCF and LCM, very good question I have brought up here in this video. And proof of irrationality. Proof of irrationality is the one topic from this chapter from which one question is compulsory, mandatory. There will be compulsory one question will be in your question paper in board exam. If you can ask to your seniors who have given their board exam and got the result, they will tell you everything, the importance of this proof of irrationality. So one question is compulsory. At least one question is compulsory in boards. Compulsory one question comes up from this proof of irrationality, my dear champion. Okay, so let's talk about introduction to number system. So first we will be talking here real number and real number chart. Basically, what are called real numbers? If I talk about real numbers, so basically the numbers, if I tell you, my dear champion, it is the union of, it is the combination of all rational and irrational number. It is the combination of all rational and irrational numbers. I hope you know rational and irrational number. All rational and irrational number fall in this number. Means I can say simply the number whose existence is clear, whose existence we can see. Like if I write -5, -3, 2/3, 2/5. So they exist basically. We can show these numbers on a number line. We can represent the numbers. The numbers can be represented on the number line. Such numbers are called real number. Whether we talk about rational number 3/4, yes, we can represent it is on number line. If I write here 0.6, we can represent it is on number line. Even if we write our irrational number √5 can also be represented on number line. So the number whose existence is clear, the numbers, the union, the combination of all rational and irrational number, or I can say the numbers which can be represented on the number line, by following different methodology as there. So such numbers are called real number. And the other number is complex number in mathematics. In higher classes, you will be studying about complex numbers, the numbers that cannot be represented on number line. Such complex numbers are called complex number. If I write here minus under root 6, minus under root 6, can you see? Can you see here? Under root minus 6. It looks that, sir, this number is not possible. Its existence is not possible. But there is a method to show this number. We can represent this number with the help of iota. Iota, that is called I. So basically this is complex number. You will be talking about complex number in higher classes when you will be studying your mathematics in class 11th. There is a particular chapter, separate chapter is there of complex number, my dear. Here in this class 10th first chapter, we are only talking about real numbers. It means that rational and irrational number. We are excluding here complex number. Okay. So now prime numbers and composite numbers, decimal of real numbers, and some questions we will be doing here. So let's move. So let's talk about a few things about real numbers. So I hope you have understood, you might have understood the basic concept of real numbers. So real numbers means what, my dear champion? In real numbers, rational numbers comes up. Rational numbers comes up as well as irrational numbers also. So it is the union of rational and irrational numbers. Right, and few things are also here. First is, my dear champion, integers. What are called integers? So integers, all the negative and positive including 0, all the values, numbers, negative, positive including 0, such numbers are called integer. If I write here minus 10, minus 9, minus 8 and so on, 0, 1, 2, 3, 4, such numbers are called integers, and it is represented by capital Z. Capital Z is the symbolic representation of integer. So the combination of negative, positive including 0, such numbers are called integers. Now if we talk about here natural numbers. So natural numbers are basically 1, 2, 3, 4 and so on. It means that the natural number starts from 1. Make sure I am not writing here 0. In natural number, 0 will be excluded and natural number represented as capital N. Right, my dear champion? The third is whole numbers. Whole numbers. So my dear champion, in whole numbers, every natural number will be there, including 0 also. Every natural number will be there, including 0 also. So 0, 1, 2, 3, 4, 5 and so on. This is called, my dear champion, whole numbers. So this is a whole number. This is natural number. I hope you are getting my point. Now the fourth point is rational number. Rational numbers. So the rational numbers are all those numbers which can be written, which can be represented in the form of P by Q, where Q should not be equal to 0. This is the format of rational number. All the numbers which can be written in the form of P by Q, where Q should not be equal to 0. For example, let me show you a few examples, like 4 by 7, like 0. 0 means 0 can also be written as 0 by 7. The condition for the rational number is denominator should not be equal to 0. That's it. So 0 is also a rational number. And one more rational number I can write here, 1 by 3. So these are rational numbers. Because, you know, numerator P by Q, P by Q, P by Q. Q should not be equal to 0. Denominator should not be equal to 0. Now, after rational number, the next number comes up is irrational number. Irrational number. Irrational number is just opposite of rational number. Rational number is what, my dear champion? The numbers that can be written in the form of P by Q, where Q should not be equal to 0. And the irrational number are all those numbers which cannot be written in the form of P by Q. The numbers which cannot be represented in the form of P by Q. It means the number which cannot go in the fraction form. The numbers which cannot be written in the fraction form. If I write here, under root 5. Under root 5. This is non-terminating, non-repeating. Under root 5. 2.23, different numbers randomly will be coming after decimal. So root 5 cannot be written in the form of p by q. Root 7, root 2, 2 plus root 5, they all are rational numbers, because these numbers under root 5, under root 7, under root 2, they cannot be written in the form of p by q. They cannot be written in the form of p by q. Such numbers are called irrational numbers. Such numbers are called irrational numbers. I hope you are getting my point. One more example of irrational number is pi also. 3.14, and different randomly the numbers will be coming there. If the numbers are repeating decimals are there, like if I'm right here, like 10 by 3. 10 by 3 means 3.3333. It will be coming gradually. So 3.3 bar it can be written as. So if the decimal is repeating decimal is there, so such numbers can be written in the form of p by q. Right, there is some method. You have already studied this concept in previous class, in class 9th. So if the decimal is repeating, these numbers, such numbers can be represented in the form of p by q, and that is the reason why this is called rational number. This is called rational number. But the number which cannot be written in the form of p by q, all the numbers are irrational number. I hope this is clear to you all. Integers clear, natural number clear, whole number means 0 will be included, rational number clear, and irrational number clear. Moving to next part. The next part comes here is, the next part is very important, prime numbers. Let's talk about, my dear champion, prime numbers. Very easy. Very easy. Prime numbers are all those numbers which are having factors as one and itself. Sir, I couldn't understand what you are saying. Okay, bacha, just listen. The numbers that can be divided by itself and 1. If I ask you 17. Now if I ask you by which numbers 17 can be divided, so you will be saying, sir, 17 can be divided by 1 and 17 can be divided by itself 17. Only two factors are there. 17 is having only two factors. 17 can be divided by 1 and it can be divided by 17 itself. If I ask you 5, tell me how many factors 5 has. So 5 can be divided by 1 and itself 5. So all those numbers which are having only two factors, 1 and itself, such numbers are called prime numbers. But if I ask you, tell me, my dear, for 6, how many factors 6 has? I mean, by how many numbers 6 can be divided? So you will be replying me, sir, 1 is evergreen. 1 can divide any number. So 1 is evergreen. I agree. Yes, 1 is evergreen. So 1 can divide 6. 2 can divide 6. 3 can divide 6. And 6 can also divide 6. So there are how many factors, my dear? How many factors, my dear? 4 factors. How many factors are there, my dear champion? 4 factors. So that is the reason why this number is called composite number. This is called composite number. The numbers which are having factor other than 1 and itself. It means three or more factors will be there. But if the numbers are having only 2 factors, the numbers are called prime numbers. I hope this is clear to you. I hope this is clear to you all. So the numbers which are having prime factor, so let me write definition for you, my dear champion. I hope this concept is clear to you. So the numbers which are having two prime factors as 1 and itself. The numbers which are having 2 prime factors as 1 and itself, such numbers are called prime numbers. Example, I can write here. So the first prime number is basically 2 is there. 3 is there, 5 is there, 7 is there. No, 9 will be not there, 9 will not be there, 10 will not there. So the next prime number will be after 7. Which will be there, my dear champion? After 7 will be 8 will not be there, 9 will not be there, 10 will not be there, 11 will be there, 12 will not be there, 13 will be there, etc. Such numbers are called prime numbers, my champion. So I hope this is clear to you. 2, 3, 5, 7, 11, 13, etc. and so on, right? Let me tell you one very important thing. You might be thinking, sir, where is 1? Where is 1? So basically, champion, please keep it in mind. I'm writing here, 1 is neither a prime nor a composite. Please keep it in mind. There is an exception with 1. 1 is not a prime nor a composite. Please keep it in mind. 1 is neither a prime nor a composite number. Please keep it in mind. Okay, moving to next part. The next topic is composite number. Composite numbers. So composite numbers are just reverse of this. In prime numbers, how many factors are there of each number? 2 factors. Itself and 1. In composite number, there will be some more factors. Other than 1 in itself, there will be there will be much more number of factors. I mean, the number of factors will be more than 2. Simple. The number of factors will be more than 2. Such numbers are called composite numbers. Do you want to see the example? So I don't need to write the definition here. You all have understood it. So example, if we talk about the example, the first composite number is 4. Please keep it in mind. The question may appear in your exam. What is the first composite number? So first composite number is 4. Why am I writing 4 here? Because 4 can be divided by 1, 2 and 4 itself. So how many factors are there? 3 factors. Apart from 1 and 4, one more factor is there, which is 2. So how many factors are there? 3 prime factors. It means that 4 is the first composite number in number system, right? But if we talk about which number is the first prime number, which number is the first prime number? So my champion, 2 is the first prime number. Please keep it in mind. This question may appear somewhere in your test, whatever, in your predictive text or in any example. This question may come in front of you. So 2 is the first prime number and 4 is the first composite number. And apart from 4, there are so many composite numbers. So after 4, 6 will be there, 8 will be there, 9 will be there, 10 will be there, 12 will be there, and so on. Why? 6 is having prime factor 1, 2, 3. Oh my God. 6 is having 4 prime factors. 8. If we talk about 8, so 8 can be divided by 1, 2, 4 and itself 8. If we talk about 9, 9 can be divided by 1, 3 and 9. 3 common factors. If we talk about 10, 10 can be divided by 1, 2, 5 and 10 itself. If we talk about 12, 12 can be divided by 1, 2, 3, 4, 6. Oh my God! Look at how many prime factors 12 is having. 1, 2, 3, 4, 5, 6 prime factors. So it is purely composite numbers. So I hope you are getting my point. Right, my dear champion? So this is the difference between prime and composite number. Very powerful topic. Okay. So please note it down. If you want to take a screenshot, take a screenshot. And if you are watching this video with your notebook, this is very good. Okay, moving to next topic. The next point is my champion, co-prime pairs. So basically co-prime numbers always comes in pairs form. When we write 2 integers, 2 numbers, so there is a relationship between the numbers. Such pair is called prime pair or co-prime pairs. So let me tell you which such numbers, what are those numbers which comes in pair and they are called co-prime. So let me give you the example here. So basically you have to keep in mind one thing. So the numbers which are having HCF, come on, the numbers, the pairs of 2 integers which is having HCF you all know, highest common factor. So the numbers, the pair of integers which is having highest common factor as 1. Please keep it in mind. Do you know what is called HCF? Do you know? Listen, my dear, let me give you an example here. So if I write here number 2 and 6, and I'm asking you HCF of 2 and 6. So what is mean by HCF? First, understand this term. So HCF is basically called highest common factor. It means the number which can divide both, the highest number which can divide both, that number is the HCF. Are you getting my point? HCF means what? The highest value, highest number which can divide these two numbers. Just think about this, 2 and 6. Which is the highest number? Which is the highest number which can divide both? So I think 2 is the highest number which can divide both. 3, if we take 3, it might be shuffling in your mind, sir. We can take 6, we can take 3. Just take 3. So if you are taking 3, 3 can divide 6, but 3 cannot divide 2. If you are taking 6, 6 can divide 6, but it cannot divide 2. We want that number which can divide both. So HCF will be 2. Are you getting my point, my dear champion? So in between 2 and 6, what will be the HCF? I'll be giving you the concept how you can find out the HCF of bigger number. These are very smaller numbers, so we can just use our common concept to get the number. But we'll be solving number of questions today in this video, don't worry. So HCF is what, my dear? The number which can divide both. Now come to LCM. LCM is called lowest common multiple. Look at the difference. First, understand the concept of HCF and LCM. HCF is the number which can divide the numbers, and LCM is the number which can be divided by these two numbers. Do you understand? Did you understand what I said here? The number which can divide the given numbers is called HCF, and the number which can be divided by these two numbers, the lowest number. So the lowest number I think will be 6. 6 can be divided by 2 and 6 can be divided by 6 also. So 6 will be the LCM, right? And HCF means this number can divide these two numbers. Are you getting my point? So this is the difference between HCF and LCM. Don't worry if you might be confused here, sir. I'm not getting it, sir. How you got the value of HCF and LCM? Don't worry. There are number of questions we'll be talking about on HCF and LCM. So don't worry. Have patience. Okay. So, my dear champion, HCF, I hope you have understood the concept of HCF. Now, a very one question I'm giving you here. Just first question. So, my question is, find the HCF. Find the HCF between 5 and 7. My question, look at the question. Find the HCF between 5 and 7. Now, can you see, my dear champion? HCF means what? The number which can divide both. So, there is no any number. There is no any number which can divide 5 and 7 both as well as. There is no any number. But there is a very powerful number which is called as 1. Yes, my dear champion. 1 can divide 5 and 1 can divide 7 both. 1 is the only number which can divide these two numbers. So here HCF will be 1, and this 5 and 7 are called what, my dear champion? Co-prime pairs. I hope this is clear to you all. If the numbers are having HCF only as 1, so such numbers are called co-prime pairs. Such numbers are called co-prime pairs. Now, if I ask you, just tell me whether this number is co-prime or not. 2 and 9 is the co-prime pair or not? Yes, 2 and 9 is also co-prime pairs because here HCF is only as 1. Now, if I ask you, so this is co-prime pair. Now, if I ask you, 5 and 20, are they co-prime pairs? No, they are not co-prime pairs. They are not co-prime pairs. Listen how. Listen, champion. Because here, how many common factors will be there? Common factors. Find out the common factors. So, common factors will be, it means which numbers can divide these two numbers. So, 1 can divide both the numbers. 1 can divide 5, 1 can divide 20, and 5 also can divide both the numbers. 5 can divide 5 and 5 can divide 20 also. So how many common factors are there? 2 common factors are there, 1 and 5. So this is not co-prime pairs. So what is the condition for co-prime? The co-prime numbers are those pairs which are having common factor as 1. Which are having common factor as 1. I hope you are getting my point. You all are getting my point. I hope this is clear to you. Moving to next. So look at the few questions here. Let's solve. I hope these things are clear to you all about numbers, prime and composite numbers, co-prime pairs, very important. So let's solve these questions. Few questions for you. Are the following statements true or false? So these are true or false question. So look at the first question, champion. Every whole number is a natural number. No. This is absolutely false. The question is every whole number. Do you know? And we have to justify. Give reason for your justification. Do you know, my dear? The whole numbers are 0, 1, 2, 3 and so on. And the natural numbers are 1, 2, 3, 4 and so on. And if we talk about integer in second question, integer, what is there? So let's write integer also. So integers are, let's say, -4, -3, -2, 0. These are positive value, 1, 2, 3 and so on. And the other is a rational number. Rational is represented by q. So this is 4 by 7, -2 by 5, 0, 1 by 2. These are the rational numbers. So let's solve the question here now. Okay, so the first question is every whole number is a natural number. Whole number means 0, 1, 2. So every whole number is a natural number. No, in natural number 1, 2, 3, 4 are there. But in whole number 0 also comes up. So 0 is not present in natural number. So every whole number is a natural number. This is absolutely false. False. The first question is false. Now every integer is a rational number. Every integer. Look at my dear champion. These are the integers. These are the integers. And of course they all are the rational number. Why? Yes, my dear champion, if you can see here -4, so -4 can be also written as -4 by 1. -4 can also be written as -4 by 1. So this is the property. This is P by Q format, -4 by 1, 0, 0. Yes, my dear champion, 0 can also be written as 0 by 3, 0 by 5. So these are the format of P by Q. It means that every integer is a rational number. This is absolutely correct. True. Third is every rational number is an integer. Every rational number is an integer. So let's check it once. So my dear champion, if we talk about every rational number, so let's check it once. So these are the rational number. 4 by 7, -2 by 5, 0, 1 by 2. These are the rational number. And do you know integer? These are the integers. Only pure number, -4, -3, -3, -2. Yes, but if we take a rational number 4 by 7, so 4 by 7 not comes in integer. 4 by 7 is rational number, but 4 by 7 will not fall in the category of integer. So every rational number is an integer is the wrong statement. So this is absolutely false. I hope this is clear to you all. Every rational number is an integer is absolutely false. So first is false, second is correct, and third is false. Okay, is it clear? Please note it down. This is the justification. I hope this is clear to you all. So moving to the next question. Now again, true false question. Are the following statements true or false? Give reason for your answers. Okay, look at the first option. Every natural number is a whole number. Correct. Absolutely correct. Do you know, my dear champion, every natural number, look, these are the natural numbers and they are also present here. Natural number 1, 2, 3, 4, and these numbers are present in whole number also. So every natural number is whole number. Absolutely correct. True. So the first option is true. Now the second question, every integer is a whole number. How is it possible? Every integer is a whole number. Is it? This is absolutely false. Look, my dear champion, if we talk about integer, integers are -4, -3, -2, 0, 1, 2, 3 and all. It means that here negative values are also there. Negative numbers, 0 and positive numbers. Right, my dear champion? But if we talk about whole number, the whole number 0, 1, 2, 3, only positive value, including 0. Only positive numbers including 0, it implies that every integer is a whole number is absolutely a wrong statement, false. Now, every rational number is a whole number. How is it possible? Look, my dear children, let me give you an example. If I am writing here 10 by 3, 10 by 3 is of course rational number, because 10 by 3 is basically 3.333333 and so on. Right? If I write here 1 by 2, 1 by 2 is a rational number, and the 1 by 2 is equal to 0.5. But 0.5 not comes in whole number. 3.33 not comes in whole number. These are rational number but not whole number. So every rational number is a whole number is absolutely a wrong statement, not possible in the case of decimal. In the case of decimal, whole number means just whole values, 1, 2, 3, 4, 5 positive value, whole number. They not include decimal values. No. So every rational number is a whole number, wrong statement. Now, okay, look at the question. Explain why 5 into 11 into 3 plus 3. Listen, my dear champion, I have just told you we have to prove here composite numbers. Look at the screen. Composite numbers. So do you know composite numbers? What are the composite numbers? Factors, the numbers which are having factors other than 1 and itself. The numbers which is having factor more than 2. It means the number which is having factors other than 1 and itself. Like 6. 6 can be divided by 1. 6 can be divided by 6, and 6 can be divided by 2 and 3 also. So there are 2 more factors. So that is composite number. So we have to prove here the given numbers are composite or not. So look, my dear champion, how we can prove here. So the first number is 5 into 11 into 13 plus 13. Can we take 13 as common here? So by taking 13 common, we can write here 11 into 15 plus 1. So it can be written as 13 into 11 5 ja 55. 55 plus 1. It means that 13 into 56. And if we break this, so it can also be written as, this is 56. So 56 can be written as 2 into 4 into 8 into 7. Can you see, my dear champion? 2 to ja 4 to ja 8. 8 7 ja 56. Right. So it can be written as 2 to power 3 13 into 7. Can you see here? This number, this given number is having prime factor 2, 13 and 7. So how many numbers can divide this whole number? 2 can divide, 3 can divide, 13 can divide and 7 can divide. So this is composite number. Because this number is having factors other than 1 and itself. 1 and itself whole. So many factors are there. So this is obviously composite number. Now the second number, look at the second number. This is the second number whole. Okay. So 6 into 5 into 4 into 3 into 2 and then plus sign. 2 into 1 is also there. So let's write 1 also. Okay. So 1 is also there, my dear champion. So this is 1. 1 plus 5. What we can do here? Modification. We can take 5 as common. So if we take 5 as common, this will become 6 into 4 into 3 into 2 into 1 plus 1. We have taken 5 as common. So it can be written as 5 into 6 4 ja 24, 24 2 ja 48 and 48 into 3. Are you getting my point? This is 3 2 ja 6, 6 4 ja 24 and 24 into 6. So we can write here 6 4 ja 24, 48 into 3 plus 1. Can we solve here? So this will be 8 3 ja 14 2 and 8 3 ja 14 24 carry 2 and 4 12 144 plus 1. So it can also be written as 1 into 145 and 1 into 145 means what, my dear champion? 145 can be factorized. 145 can be factored by taking LCM. So let's take LCM 5. 5 to ja 10 and 4 and 5 9 ja this. So direct 29 into 1 will be there. So 5 into 29, it means that 5 square into 29. Now if I ask you how many factors this number has, so 5 and 29 as factor. 5 and 29. So this number is having So many factors. Apart from this whole number, two more factors are there. So both are composite numbers. I hope you have understood the concept, my dear champion. I hope you have understood the concept. Is it clear to all? Is it clear to all? Yes. Tell me. Very good. Moving to next. Okay. Now, here we go. Fundamental theorem of arithmetic, one of the most important topic of this chapter. Fundamental theorem of arithmetic. In short, it is also called FTA. Okay, so we'll be talking about definition, what is called prime factorization, and question we'll be doing here. So look at the definition, champion. Fundamental theorem of arithmetic. Listen, every composite numbers can be expressed as a product of prime, it means prime factors, and this factorization is unique apart from the order in which the prime factors occur. For example, 480 can be written as 2 into 2 into 2 into 2 into 3 into 5, and after modification in the form of power, it can also be written as this way. How many 2s are there? 1, 2, 3, 4, 5, 2 to power 5, 3 into 5. It is called prime factorization of 480. Listen, champion, just take a simple example. If I am taking a number here 20, I'm taking here number 20, and I have asked you to write 20 in their prime factors form, in the product of their prime factors form. You might started thinking, sir, how we can write this in prime factor form? So you guys can take LCM of this number. So if you take LCM of this number, so let's 2 will cancel this by 10, 2 will cancel this by 5, and again 5 will cancel this. We have to take LCM till 1. If 1 is up here, the LCM will be ended up. So now 20 means what? 20 can be written as 2 into 5. It means how many times 2 is there? 2 times. So 2 to power 2 into 5, and this is called prime factorization. This is called prime factorization. This is called prime factorization. Of which number? So we can write here prime factorization of 20. So 20 can be written as in the form of its prime factorization. So 20 is equivalent to 2 to power 2 into 5. Because 2 to power 2 is 4, and 4 into 5 will be 20. So this is the fundamental theorem of arithmetic. So there will be very big numbers. So you have to take LCM to follow these things. I hope this is clear to you all. So let's do few questions. Let's do few questions here. So why we are studying this method, fundamental theorem of arithmetic? Why? Because this is genuinely very important. This theorem will help you out to find out the HCF and LCM between different numbers. You guys can find out HCF and LCM between the numbers by using the prime factorization method, my dear champion. So this is very important. So let's move ahead. Okay, so a few examples are there. Look, my dear. So first, 420 is splitted into 2 form. If we take LCM 2, so 420 can be written as 2 into 210. Now 2 will leave alone. Now 220 is the bigger number. It cannot split in more parts because 2 is a prime numbers. Okay, so 210 will go in again 2 parts. So again we are getting 2 is a prime number, but this is composite number. So if 105 is composite number, so 105 will be splitted here, 35 into 3. So now 3 is a prime number. So we have to split the number till we get prime values at the end. 5 and 7 are both are prime values. Now 7 cannot be splitted more and 5 cannot be splitted more. So the door has ended. The door has closed. So this is called, my dear champion, prime values. So 420 can be written as 2 into 2 into 3 into 5 into 7, 2 into 3 into 3 into 5 into 7, 2 into 2 into 3 into 5 into 7. Can you see here? Look at the definition of fundamental theory. Look, every composite numbers can be expressed as the product of primes. As the product of primes. And can you see these are the prime values? This is the fundamental theory of arithmetic. So 420 can be written as, so how many times 2 is appearing? 2 to power 2, 3 into 5. And similarly 272 can be written as 2 into 17 is also prime number. So we cannot split it more. Now door has closed. So 272 can be written as 2 into 2 into 2 into 2 into 2 into 17. So how many 2's are there? 1, 2, 3, 4. So 2 can be written as 2 to power 4 into 17. This is called prime factorization. I hope you are getting my point. You all are getting my point. Prime factorization method. Now moving to next. Oh wow. So few questions are there. So let's solve all the questions here, my dear champion. So the first question is express given numbers as a prime factor of its prime factor, as the product of its prime factor. So if we talk about first question, so 140. So how we can write 140 in the terms of its prime factor? So I have already given you the way, the method how you guys can show. So just take LCM. So by taking the LCM, you guys can show 140 in the terms of its prime factor. So listen, solve. So for 140, if we take 140 LCM, so 2 will cancel, 70 will come. Again 2 will cancel, 35 will come. Again by 5, 7 will come. By 7, 1 will come. So 140 can be written as 2 into 5 into 7, which can also be written as 2 square into 5 into 7. And this is prime factor of 140. This is the prime factor of 140. I hope this is clear to you. Moving to next question. If we talk about 156, now take LCM of 156, because you cannot get directly due to lack of experience when you will be doing a lot of questions. So it will be clear to you how you guys can write direct. It depends on your mathematical speed, accuracy. So when you do a lot of questions based on same thing, you will be ultra pro in this. But here this is initial stage. You all are learning these things very first time. So you should follow the method procedure, just taking the LCM and all. So by taking LCM 2, so 2 will cancel, 2 7 ja 14, 2 8 ja. Now again 2, so 2 3 ja 6 and 2 9 ja. Now 3 will cancel this by 13 time, and now 13 is itself a prime number, so direct will go. So 156 can be written as, can I write direct? So 2 is how many times? 2 times. So 2 square, 3 is single time, and 13. This is the prime factor of 156. I hope this is clear to all my champion. 2 square into 3 into 13. Yes, my dear champion, let me know. Is it clear to all? Now let's talk about 3825. How we can write 3825 in its prime factorization form. You all know whenever the number is ANDed, once digit is 5, such number always divides by 5. You all know this theorem. There will be a big chance to divide by 3 also, but 5 is confirm 5 will divide that number. 3 can also be divided, because 3 5 are 15 and once digit is 5 appearing, so 3 can also be divided. So let's check it once. So third is 3825. So my dear champion, by taking LCM, so let's check how many prime factorization this number has. So 3, let's check 3. So 3 1 ja 3, and this is 8, 3 2 ja 6, 1 2 3 4 ja 12, and we are getting here 3 1 ja 3, and this is 3 2 ja 6, and we are getting, oh sorry, why I am writing here 4? I think 22 is there, so 7 will come. Yeah, 3 2 ja 6, 2 2 22, 3 7 ja 21, 3 5 ja. Now again, can we check 4 3, 3 4 ja 12? Yeah, 3 can also divide again. 3 4 ja 12, and this is 3 2 ja 6, and this is 3. Yeah. Now can we check again for 3? No, 3 cannot be divided now. So 5 can divide this number. So 5 can divide 5, 8 ja 40, and 40 and 2 5. So 5 5 ja 25, and again 5 can divide this by 17. And again 17 can divide by 1. So 3825 can be written as, in the product of its prime, how many 3's are there? 2. So 3 square. How many 5 are there? 2. So 5 square and into 7. This is the prime factor of, my dear, 3825. I hope this is clear to you all champions. 3 square, 5 square into 17. 3 square, 5 square into 17. Now moving to next question. 50025. Oh, sorry, 5005. So if this number is ANDed with 5, so it is damn sure 5 will be divided in this number. So 5005. So let's check, because this is the unit place and unit place is 5. So 5 can divide this number. So let's check it once. 5 1 0 0 1. Wow. 1 0 0 1 1 0 0. Now check it one. Now the important thing starts here. The important one, 1 0 0 1. Which number can divide 1 0 0 1? Now this is the task here to check it once. Check, my dear champion. Which number can divide 1 0 0 1? 1 0 0 1. Which number can divide 1 0 0 1? Can you check it once? So if unit place is 1, so we can go to 7. We can check it by 7 because 7 3 are 21 and unit place is showing 1. So we can check at 7. So let's check it for 7. So 7. So 7 1 just 7. So 3 and 0 means 30. 7 4 jar 28 and 2 and 1. So 3. Wow. It is absolutely correct. Now we can check it 11 because 143 can be divided by 11. I know, you also know. So 11 1 ja 11. So 3 11. Wow. And 13 is also a prime number. This is the prime factorization. Yeah, such numbers sometimes looks very difficult to find out the prime factor, but you have to do because it's all about marks. Okay. So 505 is having prime factor. All are single. So 5 into 7 into 11 into 13. These are the prime factor values. Okay. Now moving to fifth question. 7 4 2 9. Now write the prime factor for this number. Now listen, my dear champion. I'm giving you a short trick. Listen. If the unit place is 9. Look. This is unit place. Unit place is 9. So it indicates that 2 cannot divide this number. 5 cannot divide this number. There is little bit chance 3 can divide because the unit place is 9. Little bit chances. It is not sure that 3 will divide this number. It is not sure. It is not confirmed that 3 will divide this number, or it is not sure that 3 will divide this number or not. There is chances. There is chances. There is little bit chances that 3 might divide, but it is not confirmed. Let's check some more number. After 3, 7. 7, it looks 7 can divide because unit place is 9. 7 7 is 49. 17 can divide. Yes, my dear, 17 into 17 is 289. Right? And 17 7 that is also 9 at the unit place. So it looks like, yeah, it can divide. So let's check it once. So as the numbers, this number is a little bit big number, so we can directly check it 17. So let's check 17. Let's divide by 17. 17 7 4 2 9. Okay. Divide by 17. So in 17 table, 17 5 ja 85 and 17 3 ja 17 4 ja 68. So this is 68 and this will be 6 and this is 2. 17 3 ja 51 and 17 4. So we can go to 17 3 ja 51 and this is 1 1 and this is 9. And you all know 17 7 ja 119 is there. Wow. 17 7 ja 19. It means that 17 is clearly dividing this number by 437. By 437. Yes. Now 437 is there. Now check which number can divide this. 437. So there are so many numbers. So can we check as 19? Because 19 3 are 27. Unit place is 7 is appearing. So if we check at 19, so let's check by 19. So 19 4 3 7. So 19 2 are 38. Okay, and we are getting here. This is 5 and 7. Wow. Yes, my dear champion. 19 is dividing this number by 23 times and 23 is itself a prime number. So 23 will cancel this by 1. So 7 4 2 9 is having prime factor 17 into 19 into 23. So this is the way how we can write how we can express any given number in the product of its prime factor. Okay, moving to next. Check whether 4 to power n can end with 0, digit 0 or not. Not at all. Let me tell you, never. No. But this is question, so we have to prove it here. Okay, just prove here. So my dear champion, here the number is 4 to power n. If the number is 4 to power n, it means that, my dear champion, how we can write this number? Can we modify this number? Can we write this number as as, it can also be written as 2 to power 2 and power n, if you agree. 4 can be written as 2 to power 2 into n. So it implies that 2 to power 2n will be the result. I hope this is clear to you all. 2 to power 2n will be the result. Now, if the 4n is expressed in this form, now if you put any number, any value as n as 1, 2, 3, let's assume I'm putting here n as 1. So what will be the value of 2 to power n? 2 to power n, and this will be 2 to power 2, which is equal to itself 4. Now put n to power 2. So 2 into 2 to power 2 into 2, which is equal to 2 to power 4, and 2 to power 4 means 2 4 ja 2 2 ja 4 2 ja 8 2 ja 16 is there. So can you see here, these numbers 4, 16, these numbers coming, these numbers are not ending with 0. And can you see, this number is only having one factor, which is 2. This number is not having factor 5. If the number is ending with 0, the factor must be 5 also. Because all the numbers which is ending with 0, whose unit place is 0, can divide it by 2 and 5 both. And if 5 can divide that number, so 5 should be present here. 5 is not here. So 4 to power n is only having only one factor as 2. It has no factor in the form of 5. So 4 to power n cannot end with 0. Because only one factor is there, 2. If the number 4 to power n is ending with 0, it should have factor as 5. All the number, for example, check one example. As the first example will be 10, then 20, then 30, then 120. You can take anything. You can take any number which is ending with 0. Take 40. So all these numbers can be divided by 2 and 5 both. All these numbers can be divided by 2 and 5 both. You can check it once. So all the number which is ending with 0 have both factors 2 and 5, but 4 to power n is having only one factor in the form of 2, so it cannot be ended with 0. Okay, let's move to the next concept, HCF and LCM relationship between the numbers. Okay, so we have to find out here LCM. HCF you all know, lowest common multiple, and HCF is the highest common factor, and we will be finding out by prime factorization method that we have did here. Okay. Now, relation between HCF and LCM and the questions. So, let's start with here, HCF and LCM and relationship between them. So, listen, my dear champion. So, basically, let's say, if A and B are two integers, so my dear champion, please keep one formula in mind. The product of numbers itself, product of integers themselves is equal to the product of their HCF, and the product of their LCM. Please keep it in mind. This is very important formula. The product of number themselves is equal to the product of their HCF and LCM. Let me show you by taking an example. So let's take an example. So I'm taking here example of 12 and 15. Check it once, just simple example. So let's find out. So here 12 is A and 15 is B. I hope this is clear to you. Now find out the LCM. So to find out the LCM, we have to factorize 12 first. So 12 can be written as 2 to power 2 into 3. 2 to power 4, 4 into 3 will be 12. And 15, what happened? 15, some problem. 15 can be written as 3 into 5. So 3 into 5. Now, my dear champion, how we can find out LCM? Listen, champion. So first find HCF. So to find HCF, what is the full form of HCF? Highest common factor. So to find out the highest common factor, take the opposite of this. means highest, the opposite will be lowest. So take the lowest power which is common in both. Lowest power common in both. But do one thing. If you are having any confusion, do one thing. 3 is present here, 3 is present. 2 is present in the prime factor of 12, but 2 is not present in prime factor of 15. So in initial phase, you can write 2 as a 0. If some number, any prime factor is present in the prime factor of first number and that is not present in the second number, so you can take power 0. Similarly, 5 is here, but 5 is not there. So we can take 5 to power 0. Because anything having power 0 is equal to 1. So writing or not writing, both are equivalent. So we can show. Okay. Now in HCF, take the lowest power, lowest common power. Come on. For highest common factor, take the lowest common. Means if you are finding the highest common factor, you will have to take the lowest common power of their prime factors. So if we talk about 2 to power 2 is here and 2 to power 0 is here. So which we have to take lowest power. So 2 to power 0 will come. Yes, my dear champion. Now if we talk about 3, so 3 to power 1 here and here also 3 to power 1. So only 3 to power 1 will come. Now if we talk about 5, so 5 to power 0 here and 5 to power 1 here, which we have to take lowest. Come on, lowest, because we are finding HCF, highest common factor. So for highest common factor, you have to take lowest power. So it will come 5 to power 0. So can we find 2 to power 0 is nothing, 1. 5 to power 0, nothing, 1. So 3 to power 0 is answer. So here the HCF will be 3. And you can verify also, my dear champion, 3 can divide 12 and 3 can divide 15. Yes, my dear champion. This is the HCF. Now moving to LCM. LCM is the lowest common multiple. Come on, lowest common multiple. Which term is here? Lowest. So which power you have to take? Highest. So for lowest common multiple, highest power will come. So if we talk about 2, 2 to power 2 is here and 2 to power 0 here in this prime factor. So 2 to power 2 will come because this is the highest power. If we talk about 3, 3 to power 1, both is similar. So that will come directly. And if we talk about 5, 5 to power 0 and 5 to power 1, which will be considered? 5 to power 1, because we are finding here LCM. Now can we multiply? So LCM will be 2 to power 4 into 5 3 is 15. So this is the 60, and 60 is the number which can be divided by 12 also and 15 also. So LCM is the number which can be divided by these, and HCF is the number which can divide these. Come on, HCF is the number which can divide the numbers, and LCM is the number which can be divided by the given numbers. This is the difference. So you have HCF 3 and you have LCM at 60. Now verify this formula whether it is correct or not. So if we talk about A and B, so A is 12 into 15 and LCM into HCF. HCF is here 3 and LCM is here 60. So can we please verify 12 into 15 is 180. Oh wow, verified. Hence verified. The formula is absolutely correct. Danger formula, powerful formula. The product of any two integer is equal to the product of its LCM and HCF. Moving to next. Let's do some question here. So we have to find out the HCF and LCM of these three numbers. Okay, so find the HCF and LCM of 60, 84, 108 using prime factorization method. Again, same question. So what we have to do here? So let's find out the prime factor of all these three numbers first. So for 60, the prime factor will be equal to 2 into 12, 3 is 50, 12 and 12 5 is 60. Check it once. 2 2 is 4, 4 3 is 12, 12 5 is 60. So 60 can also be written as 2 to power 2 into 3 into 5. I hope this is clear to you. Next number is 84. So the prime factor of 84 will be equal to 2 into 4. 3 is 12, 12 7 is 84. So it can be written as 2 square into 3 into 7. Clear? Now if we talk about 108, so 108 can be written as 2 into 3 into 3 into 3 into 3 into 3 into 3 into 9, 9 3 27, and 27 into 2 will be 54, and one more 2 will be equal to 108. I hope this is clear to you all. 2 into 2 into 3 into 3 into 3, 3 3 are 9, 3 are 27, 27 to 54, 54 to 108. So it can be written as 2 to power 2 and 3 to power 3. Now find out the HCF. So I have already told you, my dear champion, for HCF always take the lowest power. Lowest power, give value, give priority to lowest power. So can you find out, if we talk about 2, so 2 to power 2 here, 2 to power 2 here, 2 to power 2. So 2 to power 2 will come because it is present in all three. If we talk about 3, here 3 to power 1, 3 to power 1 and 3 to power 3. But which will be considered? 3 to power 1. Lowest power, because we are finding out here HCF. Now, if we talk about 5, 5 is here, but 5 is not present in this prime factor. 5 is not present in this prime factor. So we can imagine 5 is here with power 0. 5 is here with power 0. So which will be the lowest power? 5 to power 0. So we can ignore this. So HCF is equal to 2 to the 4 and 4 to the 12. This is the myself HCF. Now find out LCM. So for LCM, we always take the highest power prime factor, highest power prime factors, highest power. Please have patience. Highest power. Now look at 2. 2 is 2 to power 2. 2 to power 2. This is the prime factor. This is the prime factor, and this is the prime factor. Okay. So 2 to power 2, 2 to power 2, 2 to power 2. So it will considered. It will be considered because 2 to power 2 present in all. Now if we talk about 3, 3 to power 1, 3 to power 1 and 3 to power 3. So which will be considered? 3 to power 3, my dear champion. Highest power, because we are finding out LCM. Now anyone is there? No. Now if we talk about 5, 5 to power 1 is here, 5 to power 0, 5 to power 0. Which will be considered? 5 to power 1. Why? Because we are finding out LCM. So 5 to power 1 will be there. So can we multiply? 2 to the power 4 will be there. 3 3 are 9, 3 are 27 into 5. So 27 4 is 4, 80, 28 and 10, and this is, so we can multiply here. 5 is 40 and 0, 5 5 5. This is the answer. LCM will be equal to 540. LCM will be equal to, my dear champion, 540. Is this correct or not? Oh, sorry, champion. How? Where is 7? Where is 7? We have ignored 7. So this will not be LCM. A silly mistake can lead loss of marks. Look, this is 7. We are ignoring 7. 7 is here. This is 7. 7 is here. But 7 is not here. So we can write here 7 into 0. 7 is here. We can write into 7 into 0. So 7 into 0. 7 to power 0. 7 to power 0. 7 to power 1. 1 7 will also come here. We cannot ignore 7, my dear champion, right? 7 will also come, highest power. So into 7. Now can we please multiply all the numbers? So 4 into 27, this will be equal to 2 to 28, 108, and this is 108 into 7 5 ja 35. Can we please multiply 108 into 35? 108 into 35, this is equal to 40, 5 1 ja 5, 8 3 ja 24, 2 3 1 ja 3. So 0873. Wow, this is the LCM 3780. So this was the first question. That's why I'm solving for you, so that you guys can see the solution, so that you guys should have the clarity how to solve, how to find out HCF and LCM by prime factorization. Otherwise solution is given here. Solution is given here, my dear champion. Okay, so the 60 is having prime factor of this, 84 is having prime factor of this, 102 is having prime factor this. Now to find out LCM, always take the highest power. Always take highest power. So 2 to power 2, 2 to power 2, 2 to power 2 is present in all. 3, here is only 1 3, here is only 1 3, here is 3 3. So which will be considered? 3 3, because we are finding out LCM, right? And 5 5 is only 1 5, here is not 5, here is not 5, so only 1 5 is there. 7 7 is here, but 7 is not present here and here, so only 1 7 is considered. So 3780 is the correct answer. 3780. Moving to next question. Look at the question, my dear champion. If A is equal to this number and B is equal to this number, and we have to find out HCF. So my dear, this is the first number and this is the second number. And you all know, to find out LCF, we always take the lowest power. Lowest power of prime factors. Lowest power of prime factors. So look at the solution here. So it is given that A is equal to 2 to power 2, 3 to power 3 and 5 to power 4. B is equal to 2 to power 3 into 3 to power 2 and 5. So for HCF, I have already told you, product of smallest power means lowest power, same, smallest power of each common prime factor. Each common prime factors, we can mention here common also, lowest power of common prime factors. So 2 to power 2 is here, and can you see 2 to power 2? So 2 to power 3 is here. So which is common in both? Which is common in both? 2 to power 2 is common in both. So we are taking 2 to power 2. Now if we talk about 3 to power 3 is here and 3 to power 2 is here, which is common? So in 3 to power 3 and 3 to power 2, 3 to power 2 is common, which is present in both. So we are considering that. But if we talk about 5 to power 4 is here, and here 5, only 1 is 5. So which is common here? Only 1 5 is common. That's why we are taking only 1 5. So 2 to power 2 will be 4, 3 to power 2 will be 9, 9 into 5 will be 45. So 4 into 45, by multiplying this you will be getting here 180. This is the answer. So result will be 180. Moving to next question. Find the LCM and HCF of 510 and 92 and verify the formula. Verify LCM into HCF is equal to product of the number. So 510 can be written as 2 into 3 into 17 into 5 into 1. This is the prime factor of 510. If you multiply these numbers, you will be getting 510. 92 can be written as this. 2 into 2 into 23. 2 into 2 will be 4 and 4 into 23. 4 into 23 is equal to 92. So this is the prime factor of 510. This is the prime factor of 92. Now we have to find out here LCM and HCF both, because we want to verify the formula, right? So for LCM we always take the highest common factor, highest power of common factor. So for LCM, highest power, 2 to power 1 is here. If we write this as 2 to power 1 into 3 to power 1 into 17 into 5, and it can be written as 2 into 2, 2 square into 23. Now which is the highest power? 2 to power 2 is the highest power, so we are taking 2 to power 2, right? Here is 3, but here is not 3, so we can consider 3 to power 0. So only 3 will be common. Similarly 5 is here, but 5 is not here, so only 5 is common. 17 is here and 23. By multiplying this, we are getting 23,460 as LCM. And for HCF means what, my dear? Lowest power. So lowest power means 2 to power 1 will be there. Now if we talk about 3 is here, but 3 to power 0 is here. So which will be considered? 3 to power 0. So we can ignore. Similarly 17 will be ignored and 5 will be ignored, because 17 is present in that prime factor which is not present here. 5 is present in the prime factor of that number, but it is not present here. It means which is common? 5 to power 0. So only 2 will be considered here. Only 2 will be considered, because here is 2 and here is 2. This is common. This 2 is common in both. This 2 is common in both. That is why this is the highest common factor. So now we can verify. If we multiply the numbers itself, the product of 510 and 92 is equal to 46,920, and by multiplying the product of LCM and HCF, if you multiply LCM and HCF, we are getting the same number. It means that it has verified. Hence HCF and LCM is equal to the product of 510 and 92. Moving to next question. Given that, so we have two numbers. This is A and this is B, and their HCF is equal to 18. We have to find out LCM. What will be the LCM? So my dear champion, we have this formula. HCF and LCM is equal to product of two numbers. So 18 into LCM. 18 is what? 18 is what? 18 is given here as HCF. 18 is HCF. So 18 into LCM is equal to product of the number itself. This is A into B, right? So LCM will be equal to 250 into 594. This number will go there and 18 is dividing. So 18 will be dividing the product of these two numbers. So we are getting 8,316, which is the LCM. So by using just this formula is very important. LCM into HCF is equal to product of two number. This is given here. This is given here. In this question, HCF is given here, right? And we have to find out LCM. What will be LCM? We can find. Next question. Is it possible to have two numbers whose HCF is 18 and LCM is 760? Give reason. So the question is it possible that there will be two numbers whose HCF is 18 and LCM will be 760? Is it possible? So give reason. We have to check. Give reason. So my dear champion, check it once. How we can find out? So let's say if we want the number which is having, what happened? Just a second, some technical problem. Just a second, guys. So we are here. We have done with this question. Done. Yeah, we are at this question. So the question is it possible to have two numbers whose HCF is 18? HCF means that numbers which is possible or not, just we'll be checking it. So that number is dividing by 18. 18 is the HCF. So 18 will be dividing both the numbers. So we can assume here. So we can assume the question is saying here. Yeah. So find the numbers of possible pairs. We are here. Yeah. So is it possible to have two numbers whose HCF is 18 and LCM is 760? Give reason. So just check it once. So let the numbers be. Let the numbers be 18x and 18y. Why I'm taking this 18x and 18y? Because both the numbers are having HCF as 18. So we can assume, we can suppose the number will be 18x and 18y. So these are the numbers, right? Okay. Now their LCM is 760. My dear champion, just imagine if we have assumed these are the numbers. So the product of numbers will be equal to the product of their HCF and their LCM. We have this formula. If we have assumed this is the number 18x and 18y, so we can write this formula. The product of the number itself is equal to the product of their HCF and LCM. Now, can we take here 18 common? So 18 into xy is equal to 18 into 760. Now check, my dear champion. If this 18 will go there, 18 is dividing this and this. So 18 should be dividing this. So it is clear that 18 is dividing 18. But is it 18 dividing this number or not? Check it once. 18 is dividing 760 or not? This is the question here. 18 is dividing 760 or not? This is the question. Here clearly 18 is dividing 18, but it is dividing 760 or not? This is the question. Check it once. Please divide it. Divide it. Divide it. Yes, is it okay or not? Yes, tell me, my dear champion. Yes. Listen. So here 18 should also divide 760. But here if you check 760 divided by 18, so you will be getting remainder as 4. Yes, my dear, you can check it. Remainder will be 4. Means 760 is not perfectly divided by 18. 760 is not dividing perfectly. 760 is not divided by 18. It implies that there will be no any such number possible whose HCF will be 18 and whose LCM will be 760. Not possible. Not possible. It is not possible that there will be the pair of numbers whose LCM will be 760 and HCF will be 18. Not possible, my dear champion. Please keep it in mind whenever you are solving such question. Please keep it in mind, champion. So please take a screenshot if you want to take a screenshot. Is it clear? You can keep one thing in mind. See, my dear champion, HCF is always, if you have written down, please write this line also. HCF is always a factor of LCM. Always keep in mind, a factor of LCM. HCF of any two integer is a factor of its LCM also. But here if we are checking here, if we are checking 18, if we divide 18 to 760, 18 is not dividing perfectly to 760. It means that 18 is not the factor of 760. It implies there is no such possible pairs is possible. There are no any possible numbers whose pair, there are no possible pair whose HCF will be 18 and the LCM will be 760. Because HCF is itself the prime factor of LCM. Any number, you can check it in anything. Let's just example. Let's check it once. 12 and 15. So for 12 we can write 3 into 2 square. 15, for 15 we can write 3 into 5. So what is LCM here? LCM will be 3 into 5 into 2. Right, my dear champion? So 5 3 is 15. What is this? 3 into 3, 5 into 5 and 2 square. This is, so 2 to 4, 4 5 20. This is the LCM 60 and HCF will be equal to LCF will be equal to, I think 3 is there, only 3 is there. So this is the HCF. Now can you check here, my dear? The HCF is 3 and LCM is 60 and 3 can divide this 60 also. So HCF is itself a factor of LCM. Please keep it in mind. So if HCF can divide LCM, it means this is possible. But here HCF 18 is not dividing 760 perfectly. So this is not possible. Moving to the question. Find the number of possible pairs if the product of two numbers and HCF are this and this. Okay. So we have to find out the number of possible pairs if the product of two numbers. Okay. So let's say there are two numbers whose product is this and HCF. Oh my god. If HCF is 15, so we can write the first number. We can write the first number as 15x and the second number as 15y. Why? Because both the numbers will be divided by this. So we can multiply 15x, 15y. So we have solution here. So let two numbers be 15x and 15y. And here in this question, the product of number, this is the product. The product of number is also given here. So the product of number means 15x into 15y is equal to 400, 4500, 4500. So we are getting here xy is equal to 20. Now we have to make the pair whose product will be 20, but make sure here x and y are co-prime. Here x and y are, how we are getting xy is equal to 20? Listen, 15x into 15y. So x into y and 15 into 15 is 25. 25 will go there. So after dividing 4500 by 225, we are getting 20. And we have to find out the pair of x and y whose product will be 20, but x and y both are co-prime. So the first pair will be 21. 20 and 1 both are co-prime and 5 into 4 both are co-prime. So how many pairs are there? There are only possible pairs is 2. So whenever some number is divided by anything, if the HCF is something which is given to you, so we can consider the number. If HCF is 10, so the number will be 10x 10y. If the HCF is 6, the number will be 6x and 6y. Now procedure. Next question. The HCF of two number is 6. Again same thing. If the HCF of two number is 6, it means the first number The first number will be equal to 6x and the second number will be equal to 6y. Why? Because HCF is 6. Now, their sum is 60. Now we have solution here. Look, let the numbers be 6x and 6y. And their sum is 60. So 6x plus 6y is equal to 60. Once you got the number, now follow the question, the language, the information given. So 6x plus 6y will be 60. So x plus y will be 10. Now for this condition x plus y is equal to 10. For this condition you have to find out the pair, co-prime pairs. So what will be the first co-prime pairs? I think 1 and 9 will be there because both are co-prime. And the second pair will be 3 and 7. So how many pairs are possible? How many possible pairs? 2 pairs are possible. So this is the answer, my dear. So find the pairs. So there are 2 possible pairs. Next question. If the HCF of 408 and 1035 is expressible in the form of OK. So there are 2 numbers. This is A and this is B. And their HCF is given in this form. 1032M minus 408. And this is into multiply X. Into 5 is there. Then find what will be the value of M here. Okay. So again we are applying here prime factorization method to find out the HCF in number form. So 408 can be written as this, 2 into 2, 4 into 8, 8 3 are 24, and 24 into 17. 24 into 17 is equal to 408. So this is the prime factorization, which can also be written as 2 to power 3 into 17 into, and 1032 is having prime factor. 2 into 2 into 3 times 2, 2 to power 3 into 3 into 43. This is the prime factor. Okay. Now what will be the HCF? For HCF, we always take least power. So what will be the HCF here? Least power 2 to power 3, and for 17 power 0 will be least because 17 is not here, so we can assume 0. 43 we can assume here 0. So which will be least? 17 to power 0, we can ignore that. 43 power 0 will be lowest, we can ignore that. So only 2 to power 3 will come and 3 will come, so HCF will be 24. But here in this question, HCF is given in this form, so we can equate here. This here, 24 will be equal to 1032M minus 408 into 5. That is the HCF format which is given. By solving it, by doing the mathematical calculation, we got here M is equal to 2. This is the answer. Moving to next question. The HCF and LCM of 2 numbers are 8 and 48 respectively. If the ratio of 2 numbers is 2:3, then what is the larger of the 2 number? Very easy question. Listen, if HCF is 8 and LCM is equal to 48, what do you understand by this? So the first number will be equal to, this is 8 is here, so 8x, and the second number will be equal to 8y. I hope till here nothing is there challenging here. 8x and 8y. Now both the numbers, if the ratio of the 2 numbers is 2:3, okay, so the numbers are already given in the ratio. So can you see here, my dear champion? So if the ratio of the number, it means we can write 2x into 3x. We don't know the number, but here is ratio given, so we can write 2x into 3x. If the already ratio is given, so we can take any constant x. So 2x ratio 3x. Now according to the question, what is the HCF? HCF is 8, means 8 will be divided both the numbers. So x will be here 8. So the larger number will be what, my dear? In 3x and into 2x, which will be larger? So this is 2x. If we put here 8 into 2 will be 16. 8 into 3 will be 24. So 8 into 23 will be the larger number, because the question is asking find out the larger number. You might be thinking, sir, how it came? Oh, my dear, if your number is 2x and 3x and HCF is 8. So what do you understand by this? Look, 2x can be written as 2 into x and 3x can be written as 3 into x. Now, what is HCF here? HCF means what? The common value. So in prime factor of 2x, 2 into x, and the prime factor of 3x, 3 into x, which is common? X is common. That is why X is the HCF. And in the question, HCF is already given as 8. It means that here X is equal to 8. And once you get the X 8 in this question, we have to find out the larger number. So in 2x and 3x, which will be the larger number? Of course 3x. So 3 into 8 will be equal to 24. This is the answer. Okay, moving to next question. The LCM of two numbers is 9 times their HCF. Okay, the sum of the LCM and HCF is 500. Find the HCF of two numbers. Very easy question. There are two numbers whose LCM is equal to 9 times the HCF. So let the numbers, we don't know the numbers. So let the HCF of two numbers be X. So if we see that the LCM is equal to 9 times the HCF. So if we take HCF as X, so what will be LCM? 9 times. So if we assume HCF as X, so LCM will be 9X. Now the sum of HCF and LCM in the question you have read there, the sum of HCF and LCM is equal to 500. So one is X and other is 9X. So X plus 9X is 100. So X is equal to 50. And once you get the 50, what you have to find out here? My dear champion? Find the HCF. So HCF is equal to what? HCF is itself X. So X will be the 50, which is the answer is X. 50 will be the HCF. So everything is a language. If you understand the language, nothing is challenging here. Okay, word problem on HCF and LCM. Let's do the word problem. So the first question is, Ravi and Shikha drive around a circular sports field. Circular sports field. Ravi takes 16 minutes. Okay, so there is a circular field. Here is Ravi. Ravi is moving on circular path and Ravi is taking 16 minutes to take one round circle. It means from here to here. Ravi is taking 16 minutes to complete one circle. Okay. While Shikha completes the round in 20 minutes. Let's assume Shikha is starting again from this point, same point, but Shikha is completing one circle. In 20 minutes. Okay, no problem. If both start at the same point, I have already told you, Ravi and Shikha both are starting from same point. It means that their initial point same. So in the same direction, means clockwise, whether clockwise or anti-clockwise. After how much time will they meet at the starting point? It means that we have to find out the next number which will be divisible by these two. It means we have to find out here lowest common multiple, the common number at which the both lie. It means both the number should divide that number. It means here in this question we have to find out LCM of these two times. We have to find out here LCM of these two times. So can we go through? Since both Ravi and Shikha move in the same direction at the same time, the method to find the time when they will be meeting again at the starting point is LCM. I have already told you LCM, because we want to find out the time at which they both will be meeting again. So that will be the LCM. So the LCM of 16 and 20 will be 80. So they will meet again at the starting point after 80 minutes. The LCM will be the answer. Next question, find the largest number which divides 438 and 606, leaving remainders 6 in each case. Okay, interesting question. So in this question we have to find out the number which divides 430. It means that number is dividing this and this, leaving the remainder 6 in each case. Remainder is 6 in each case. Are you getting my point? We have to find out that number which divides these two numbers and getting remainder as 6. So how we can find out? So first in such question what we have to do, always find out here 438 and 606. So take the prime factor of 438. This will be the prime factor. 2 into 3 square into 7 we can find out. So 2 into 3 into, so let me use red color. So here 2 into 3 square is 9, 9 into 7, so 9 says 63, 3 square 9, 7, 9 6 are, this is 438, right? So 438 can be written as 3 3 are 9, 60, 63. Something is missing here. This is not correct. So let's check it once by taking LCM. So 438, this prime factor looks wrong. So 2 2 to 4 and 2 19, right? Now we can take 3 3 7, and this is 3 3. That is the wrong thing here. 438 cannot be written in this form. This is wrong, my dear champion. So something is missing here, and that is what, my dear, 73. 73 is a prime number. So by taking 2, we are getting 219, and again by taking 3, 3 7 are 21, 3 3 are. So it will be written as, can we check it once again? 73. 73 cannot be divided by any number. 73 cannot be divided by any number. Okay. So I hope you are getting my point. Something is missing here. 2 into 2 to power 3 square into 7. For 438, this will not be the prime factor, because 3 square is 9, 9 into 7 is 63, and 63 into 2 is something else. This we are getting 1 2 is 6, and here is 438. So this is the correct here. Okay, perfect. Yeah. So this is 3 to just 6, and 73 into 6 will be 18, and 7 3 are 20, 7 6 are 42, and 42 and 143. This is the correct answer. So here is 3, and we have to write this as 2 into this is 2 into 3 into 73. This is the prime factorization of 438, and 606 can be written as 2 into 3 into 101. So here there was mistake. Okay, so for 438 we are having this 2373, and for 606 we are having this prime factorization. Now the question is, we have to find out that number which divides these two, leaving the remainder at 6. So my dear champion, always subtract the 6 from the value 438 and 606. So after subtracting the 6, what will be the result here? So when you subtract 6, this is 432 minus 6. So what will be the value? 432. And in 606 minus 6, what will be the value? 600. So the prime factorization of this will be equal to 2 to power 4 and 3 to power 3. Why? 2 to the power 4 means 2 to the 4 to the 8 to the 16. This is 16. And 3 to power 3 will 3 3 to 9 3 27. This is 27. And when you multiply 16 into 27, you are getting 432. And similarly, 600 can be written as, in prime factorization, for 2 to power 3 into 3 into 5 to power 2. Check it once. 2 to power 3 will be 2 to the 4 to the 8. 8 into 3 will be 24, right? And 24 into 10 is there. This is 2 to the 4 to the 8. 8 3 are 24, and 5 square will be 25. This is 25. So when you multiply 24 into 25, you will be getting this number 600. You can check it once. You will be getting 600. So this is the prime factor. So to find the largest number that divides this and this, what we have to find out here? HCF, my dear. So HCF will be what, my dear? HCF will be, so for HCF, you all know, always take the least value. So the least value will be 2 to power 3. If we take 3, so least value will be 3, and for 5 nothing is there, so this is the least value, 2 to the 8 and into 3, so the answer will be 24. 24 is the number when this number will divide this and this, so the remainder will be equal to 6, my dear champion. You can verify. So what we have done here, listen, my dear. So whenever such question comes up in front of you, find the number which divide these two numbers, leaving the remainder 6. So always subtract the 6 from the value. Subtract the 6. This is 432, and take the prime factorization of this. Now from 606 subtract 6. Now take the prime factorization on whatever the number coming here. Find out the HCF of that, and this will be the LCM. This will be the answer. Okay, moving to next. 3 sets of English, mathematics and science books containing 336. Okay, so English book is this 336, mathematics is 240 and science books are 96. Okay, respectively have to be stacked in such a way that all the books are stored subject wise, and the height of each stack is same. Okay, the height of books should be same. The height of book should be same. The height of book should be same. So how many stacks will be there? So we have to find. So what we can do? Just take the HCF, because we have to find out the number of stack here. What will be the height of stack? Height of stack, and height is same. It means we want that number. We want that number which divide all these three numbers, because we want to make the stakes same height. So we want that number which can divide all these three. Right, so we have to find out HCF. So again, by taking the prime factorization value, so HCF would come out to be 48. You can find out the HCF. So HCF will be 48. Now if you divide all the numbers of book, the number of books will be this 36. So when you divide number of books from this 48, because 48 the height of the stack. So how many book you can arrange? How many stacks will be there? 7. And again, for 240 books, how many stacks will be there? 5. If you divide 96 by 48, so you are getting a number of stacks. So the total number of stacks required is 14. 7 plus 5 plus 2. 7 plus 5 will be 12. 12 plus 2 will be 14. So first what we got here? First we got here height of the stack. So height of the stack will be 48. Now by dividing the number, we can get the number of stacks. Find the greatest possible length which can be used to measure exactly the length of this and this. Here in this question you can see this is meter, but here this is meter centimeter, this is meter centimeter. So do one thing, make the same unit. So 7 meter first, second will be, this is 3 meter means 300 centimeter, and 85, so 385 centimeter, 385 centimeter, and 7 meter can be written in 700 centimeter, and this is 12 meter, so 1295, so 1295 centimeter. So we have converted all in centimeter. Now find the greatest possible length which can be used to measure exactly the length this. Very good. So we have to find out greatest possible length of anything that can be used to measure these things. Means we want to get the value. We want to get the value which can divide all these three. So we have solution. Look at here. So we want to find out here HCF. Why, my dear champion? Listen, my dear. Let's just assume HCF is 50 centimeter. HCF always comes smaller than these. Please keep it in mind. And LCF will always be equal to or greater than the number. But HCF is always smaller than the numbers. And we want that measuring length which can measure these things. So that will be smaller than this, and which is HCF. So this is not the HCF, I am just assuming. So my dear champion, but just taking the here HCF. So 7 meter can be written as 700, 385, and this can be written as 1295 centimeter. Now take the HCF. You know HCF, how to take HCF? By doing the prime factorization of this, and this, and HCF will be what, my dear champion? Common value. So 5 is here, 5 to power 1, 5 to power 1, 5 to power 1. So which is common? 5 to power 1 is common. 7 to power 1, 7 to power 1, 7 to power 1, which is common? 7. 2 is here, but 2 is not here. 37 is here, but 37 is not in both. 11 is here, but 11 is not present in first and third. So we will only consider common value. So 7 5 is 35. So 35 centimeter is the possible length that we can use to measure these all length. 35, 35, 35, 35. We can measure 700. 385 we can measure 35, 35, 35, 35. 1295 centimeter we can measure by using this, whatever this is, inchy tape or measuring tape is there. So 35, 35, 35, 35. So 35 is dividing all these three. So this is the HCF. Okay. A circular field has, I am giving you this question as your homework. Please try this question. Very easy question, champion. So let me give you a short trick here. So a circular field has a circumference of 360. It means distance is given to you 360 kilometer. right? And there is a circular field. Two cyclists, Sumit. So first friend is Sumit and other is John. They both start together. Can cycle at a speed of 12 km per hour and 15 km per hour respectively around the circular field. They will meet again at the standing point after how long? It means in this question we have to find out after what time they will be meeting again. So we have to find out the time. So we don't know time. Speed, distance is there, speed is given there. So time for Sumit. Find out time of Sumit. Time taken by Sumit. Time taken by Sumit. You know time? Speed equals to distance by time. So time can be written as distance by speed. So this is equal to 360 and divided by speed. So it can cancel. So this is 30 and this is hour. So 30 hour. This is, this is in kilometer and time speed is given in 1200 km per hour. So we can write here 30 hour. So Sumit is taking to cover of this 360 km with this speed, 30 hour will time he is taking. Now if we talk about John, so John, time taken by John, what is the distance? Again 360, same distance, and the speed of John is equal to 15. This is 15 here. Is it clear? We can cancel this by 15 2 ja 30 and 15 4 ja, I think 15 3 ja 12 3 30, 15 2 ja 30 and 36 0. So 15, yes, 24 hour. He is taking 24 hour. Now after how long they will meet again? So what you have to find out? LCM, because we want that number which will come again and that will be divided by both. So we have to find out here LCM. Can you see the LCM? And LCM of 24 and 30 will be 124. 120 hours. So after 120 hours, they both will be meeting again. Okay, the traffic light at 3 different roads crossing change after 48. Again, simple question. One question I'm giving you guys, homework for you in this one short video. Please try this question by your own. Okay, so again same question is given here. LCM, we are finding LCM. Write the smallest number which is divisible by both 306 and 657. The smallest number which is divisible by both this and this. It means that what? We have to find out HCF champion. What we want to find out here? Find the smallest number which is divisible by, okay, which is divisible by this and this. So it means that we have to find out LCM champion. Yes, because here is the question is we are not finding the number which divide these two numbers. No, we are finding the number which can be divided, which is divisible by these two. It means we have to find out here LCM. Can you see the solution? So by taking the prime factorization of this, we are getting this number, and 657 we are getting this prime factorization. You know LCM. In LCM we always take highest power of common factor. Highest power of common factor. So for 3 to power 2, and here is 3 to power 2. So 3 to power 2 is common. So we are taking 3 to power 2. Okay. And here is 2 to power 1, but here is not 2. So we can write 2 to power 0. 17 is here, but 17 is not here. We can write 17 to power 0. 73 is here, but 73 is not here. We can write 73 to power 0. Now we have to find out LCM. So highest power. So 3 to power 2 is common. So highest power. Now 2 is here too, but 2 to power 0. But which is highest? 2 to power 1 is highest. That's why we are taking. 17 is here, but here 17 to power 0. But which is highest? 17 to power 1. So we are taking 17 to power 1. Similarly, 73 here, but 73 power 0. But which will be considered? 73 to power 1, because we are finding out LCM. So by multiplying this, we are getting 22,338 is the number, smallest number, which will be divisible by this. Okay, let's imagine if this question would be like, find the smallest number which can divide these two. So that will be HCF. But here is the question, find the smallest number which is divisible by these two. It means these two numbers are dividing something. These two numbers are dividing something. It means we have to find out LCM. Both are dividing. Both are dividing a number. Both are dividing a number. It means we are finding here LCM. Okay, so the next question, find the smallest number which when divided by this. Okay. So my dear champion, can you see here? These two numbers are divided some other number. It means that we are talking about LCM. If these two numbers are divided by some any number, it means we are talking about HCF. But if these numbers are dividing some other number, so we are talking about LCM, and leaves remainder 8 and 12 respectively. So we have to find out that number which when divided by these two. So when that number divided by 28, remainder will be 8, and when that number will be divided by 32, remainder will be 12. So this is the question. So very easy question. So basically I have already told you we are finding here LCM. So by taking the prime factorization of 28 and 32, the LCM will be 224. But here the remainder is 8 and 12. So what we have to do when you find out LCM? So always subtract the sum of the remainder that you are getting here. So the remainder is 8 and 12. So can you see? If you take the difference of 8 and 20, the difference is 20. And if you see the difference of 32 and 12, the difference is again 20. So this is called common difference. So subtract the common difference from the LCM. So 224 minus this 8 plus 20, which is common difference. So we are getting 224. This is the answer. So when you divide 28 to 204, the remainder will be 4. When you divide this number 32 from this number 20 from 32, the remainder here will be equal to 12. You can verify this. So 204 is the correct answer. 204 is the answer, right? So always keep it in mind. Find the smallest number which when increased by 17 is exactly divisible by, again, come on, we have to find out that number which is just ignore this statement for a while. Just ignore this statement for a while. For a little while. Now look at the question. Find the smallest number which is exactly divisible by this and this. So what we have to find out here? LCM we have to find. Yes, my dear. Because we want to find that number which is divisible by these both numbers. Right? So that will be LCM. And after getting that LCM, you can subtract this. Because 17 is increased. It means 17 is already added. So we have to decrease the 17. So 520 can be factorized by this way. You all are in expert now in prime factorization, and 468 will be factorized is this way. So what will be LCM? LCM will be 4680. But the question is, find the smallest number which when increased by 17, means 17 is already increased. So what will be that number? So reduce the 17. So the answer will be LCM minus 17. So LCM is equal to 4680. 4680 minus 17, that is equal to what, my dear champion? 4663 is the answer. Because 17 is already increased. So this is that number. If we add again 17, if we add 17 in this number, so the number that you will get will be this, and this is divisible by these two. Okay, now the last topic of this chapter is proof of irrationality. Very important theorem and question. So proof of irrationality means what? Let P be a prime number. If P divides A square, then P divides A, where A is the positive integer. So don't worry, I'll be explaining this topic in very simple way. Listen. So look at the first question. Prove that root P is an irrational number. So my dear champion, whenever such question comes up in front of you, so we always use here contradiction method. Contradiction method. So what is this contradiction? Let's check it once. This is the contradiction method. We also call this as assumption method. So when we want to prove root 5 as an irrational number, so we will be assuming root 5 as a rational number. So that is the reason why this is also called assumption method. So let's solve this question. So let's assume, let root P root p is a rational number. Root p is a rational number. So if root p is a rational number, it means that root p can be written as a by b. If anything is rational number, so rational number can be represented in the form of p by q. But we cannot take p and q here because the given number is itself in the form of p. That's why I'm taking here a by b. And here a and b, please don't forget to mention this line. Here a and b, just a second guys. Here a and b are co-prime pairs. Please make sure to write this. Co-prime means a and b both are having common factor only 1. Can you find this? Okay. So if root p is a rational number, so root p can be written as a by b. Now can we cross multiply? So we can write here root pb is equal to a. Root pb is equal to a. Now squaring both sides. Squaring both sides, what you are getting here? So root removed, so p into b square is equal to a square. Yeah, we can write pb square is equal to a square. Now if pb square is equal to a square, it means we can shift this p this side, and if p will come this side, it means a is divided by p. Here it implies that a square is dividing by p, so a is divided by p. If a square is divided by p, so a is also dividing by p, so a is divided by p. And my dear champion, can you see a and b both are co-prime? And what does it mean by co-prime? Co-prime means HCF is equal to 1. But here we are getting a is divided by p also. Now just imagine if a is divided by p, so we can bring a new parameter, and we can write if a is divided by p. Come on, can you see? If a is divided by p, so we can write a is equal to p, and I'm taking one new term which is c here. A is equal to pc. Why? Because a is divided by p. This is first and this is second. And can you put a in second equation into first? So putting second in first, so what we are getting? P into b square, and at the place of a, pc will come. So this is equal to p square into c square, and this p will cancel this. So now b square is equal to pc square. Now p is at the right side. It implies that p will be dividing b square. Oh my god. So b square is divided by p, and if b square is divided by p, b is also divided by p. So b is also divided by p, and this is what? This is contradiction. Why? Because a and b both are co-prime, and co-prime means common factor is 1. But what we got here? A is divided by p and b is divided by p. One more factor. This is the contradiction. So it shows the contradiction in our assumption. What we have assumed? We have assumed a and b are co-prime. Why co-prime? Because root p is a rational number. So if a and b are co-prime, but we got one more factor as p. A is divided by p, b is divided by p. So this is contradiction. It occurred. The contradiction is occurred. And why this contradiction occurred? Due to our assumption. And we assumed root 5 is a rational number. So our assumption is wrong. So it shows that contradiction in our assumption. So it implies that our assumption is wrong. And why our assumption has become wrong? Because assumption is rational number. So root 5 is what? An irrational number. It cannot be rational number, because by assuming it as an a rational number, we are getting a contradiction, which making the statement wrong. So it has to be irrational number. So next question, prove root 11 is an irrational number. Again, same. If we have assumed root 5 be root 11 be a rational number. So if root 11 be rational number, so it can be written as a by b. So root 11 is a by b. By squaring both side, 11b square is a square, means 11 divides a square, so 11 divides. Can you see here? Can you see here, my dear champion? On squaring both sides, and this is the most important line. A and b are the integers having no common factor other than 1. Having no common factor other than 1. It means that A and B are co-prime. A and B are co-prime. My dear champion, you can also write this statement, or else you can write this statement as well. Both are same. Okay, so 11 divides A. It means A is dividing by 11. Now, so if A is dividing by 11, we are taking one more new term, which is C's integer. So A can be written as 11C. See, if I'm saying you, my dear champion, you know, P is divided by X. So you can write this information as P is equal to, P is divided by X. So P is equal to X into something. X into something. Then X will come here, P is divided by X. So if P is dividing by X, P is divided by X, we can write that statement into P is equal to X into something. So here if A is divided by 11, we can write one more new term. A is equal to 11/7, 11C. Now it is, we are putting here again in this equation. So 11b square, and at the place of A, we are putting 11c square. So 121c square. 11 will go there. So b square is equal to 11c square. So now b square is divided by 11. Oh my God. So b is divided by 11, which is making contradiction, because this is A and B are co-prime. But here we are getting one more prime factor, which is 11. One more factor, which is wrong. So this contradicts the fact that A and B common factor as 1. We are getting one more. So why this is contradiction occurring? Because we let the here 11 is a rational number. So that's why root 11 be an irrational number. Again, we have to prove 2 plus 5 root 3 is an irrational number. So same method, let this number as a rational number. So if we let assume 2 plus root 3 is a rational number. So 2 plus root 3 can be written as A by B. Now cross multiplying. So by doing cross multiplication, so whenever such question comes up, my dear champion, always try to take root family alone. Root family alone. So root 3 can be written as, this 2 will go there. So A by B minus 2 by taking LCM. Now look at this whole function. A minus 2B by B. So this whole fraction is rational. This whole fraction is rational. Whatever you put A, B, 1, 2, 3, whatever, you will be getting a rational number. But can you see here root 3? Root 3, if any number is except perfect square, if anything is there inside the root, that is irrational number. Oh my God. Oh my God. Right side is irrational and rational, and left side is irrational, and both are equal to each other. Is it possible? Is it possible in maths? Rational can be equal to irrational? No. So this is the contradiction. A and B are integers, so this is rational, but root 3 is thus root 3 is also rational, but we all know root 3 is irrational number. Assumption, this contradicts the fact that root 3 is irrational, so our assumption is incorrect. And why our assumption is incorrect? Because we have assumed root 3, 2 plus root 3 as rational. So 2 plus root 3 will be what, my dear champion? Irrational number. This is the answer. Second question, again same question, root 2 plus root 3 is irrational number. So what you have to do in such question? Again, let this number as rational number. So we can write A by B. Now, what you to do? Take one root this side, A by B minus root 2. Now taking squaring both sides. So by squaring both sides, we are getting a 3, and this is A minus B whole square. So A minus B whole square will be A square plus B square minus 2AB. Right, my dear champion? A square plus b square, so root square will be 2, 2ab, 2a this is. So again I have already told you, always in such type of question take root family one side, root family one side, and remaining integer other side. Remaining integers other side. Please always follow this in such type of question. Root family one side, and remaining whatever except root, whatever is there, take other side. So by modifying, root 2 is single side and this is another side. So this is the format of rational. This whole number is rational, this whole family is rational, and this is what, my dear, irrational, and they both are equal, which is not possible in maths. And why this assumption, why this contradiction is coming? Due to our assumption, and we have assumed it as a rational number, which is not possible. Let us assume this. No, this is rational. Okay, so after assuming rational, we can write a by b. So this is the answer. Again, same question. So same derivation. Always take root family one side. Show that under root 3 plus root 5 square is an irrational number. Same thing. So we have to prove this as irrational number. So prove 8 plus 2 root 15. So we have opened this a plus b whole square, which is equal to a square 3 plus b square 5 plus 2ab. 2ab means 2 root 15. 5 plus 3 will be 8. So this is indirectly this number. So if you are writing this or this, both are same. We have opened the square, so after opening the square, a plus b whole square, we are getting this number. So we have to prove again. So let's suppose 8 plus 2 root 15 is a rational number, and when you have assumed, you can write a by b rational format after doing the mathematical calculation. And my method, always take the root family one side. Root family, this is the root family, so this is irrational, and this is what, my dear champion, rational, and both are equal to each other, which is not possible in maths. So this is contradiction. So a minus 8 by divided by 2 by being a rational number, root 15 becomes rational. It means if this is rational, so it has to be rational, but root 15 is not rational. So which is contradiction with the fact that root 5 is an irrational number. So we led to contradiction due to the wrong supposition, hence that this is irrational number. So thank you so much for watching this one-shot video. I hope this video will really help you out for your examination, and stay blessed, keep rocking and keep coming. And the student who is new, go and hit the subscribe button, share this channel Diksha Vedantu with your friends as well. Thank you so much for watching. Bye-bye.